Thanks for showing up early this morning. We appreciate that. I know it's tough to get out of bed. Okay, so my name is Michael Schubert. I'm with Solutions for Rebiz, a distributor of the Bequant product. Today we're going to have our spotlight vendor. We're going to talk to Gino from Aeronet. He's going to give his impression of the product. We're also going to have Jose Lopez do the product overview, and so hopefully we'll give you lots of good information. So I'd like to give a little bit of background on the product. It started out in Europe, 2016. They now have 60 plus installs. After this show, we're going to have even more. The Bequant founders come from a good pedigree. They previously founded a DPI pioneer called NetSpira Networks that was acquired by Ericsson and provided DPI functionality for their core network. From that point, they waited it out and started up a new company. Who uses this system? Wireless ISPs, fiber ISPs, cellular enterprise networks, anyone who's trying to make their network faster. So it's not specifically targeted only at WISP, and there are many WISP that are now changing over, so you're still a target if you are moving the other direction. They entered the U.S. market with us in the first quarter of 2019, so we're fairly new to this market space, and we're growing quickly. We have many satisfied and happy customers: Aeronet, Plains Internet, Genco, Splash Internet, Cherry Capital, and Cool, to name a few others coming along. So why use the product? Well, again, accelerate your network performance by up to 100%. I know that's a big number, and I was a little skeptical myself, but to point number two here, the proof is in the reports that they produce, and they can show you performance gains. And so I think that's the good news, is that they can measure and show you what you're gaining from this product. If you want to reduce your support calls on streaming, slow streaming complaints, this is, again, a great product to help you do that. There are deep packet inspection features such as shaping and visibility at a high level. Those are changing and emerging as we go. They're adding a lot of features in those areas. The good news is it's inexpensive hardware devices that handle either up to 10G or 40G. So it's not going to cost you an arm and a leg to get into this product. Of utmost consideration is it's super simple to configure and implement. So there's no integration. You don't have to hook into a bunch of users and pull in CSV files and do all that kind of stuff. If you take nothing away from this presentation, realize that you can get a free trial. We will send you a box, no commitment, to try it out. And if you don't like it, you send it back, and we will take it back with no money down on your part. The other side of this is it's very affordable, either as a monthly fee or a one-time license option. We got both options available. So that's just a quick overview. Here are our current deployments. Obviously, because it started in Europe a few years ago, they've got a critical mass there, but we're slowly growing in both North America, South America, and even other parts of the world. So, having said all that, I'm going to turn it over to Jose Lopez, president of Bequant, and he's going to give you some overview of the product, and then we'll hear from Gino after that.
Hello, good morning. Thank you for coming. And I'd like to talk about what we do and what our product can do for you. We can optimize your network, but what does that mean? Three things. We can accelerate with our TCP optimization, increase the speed that your users experience. I'll explain that later. Analytics, we can show, since we are inline and the traffic in your network is flowing through us, we can show you what is actually flowing, how much Netflix, how much YouTube, how much of different applications you have. And then based on our ability to detect and identify different kinds of traffic, we allow you to limit the speed of some of those applications if you need to, at certain points, maybe to reduce congestion and maybe for certain users. So we give you those possibilities. So let me start with the first one, what we mean by acceleration. We increase the speed experienced by your network users, which is not the same as the speed that your network provides them. Because, as an example, if you're a user at some point has maybe a channel, a radio channel that allows up to 10 megabits per second, but that user is streaming Netflix, and Netflix is sending at 5 megabits per second. 5 is what he thinks he has. And what we can do in those situations is let Netflix, in that case, use more and something closer to the 10 megabits per second that are available. And it is in this way that we accelerate, because we cannot improve the basic speed of your network. That's on you. That's the network part, your infrastructure. We can just make applications actually use it. But from the point of view of the user, that's just the same, in the sense that he will value your network for what he gets when he uses applications, not from the theoretical speed. So the next question then is, why would Netflix or anyone send at 5 if there are 10 megabits available? And the reason, and the question, the answer is transport protocols. TCP, the main one, they've been there from the beginning of internet. Great thing. They are, among other things, they decide at what speed to send at each moment. Mainly from the servers. And in our example, for instance, in the Netflix data center, they have to decide at what speed to send. If they send too fast, faster than the 10 megabits available, then they'll lose packets after a while. And if they send at 5, then they're leaving unused capacity. So TCP has to be smart and probe in a way, going from slow speeds to higher speeds to find that optimal. But in doing so, when the network, TCP can do a fairly good job normally, but if the network has wireless or packet losses or large latencies, very often at some point between this 0 and 10, it will get confused because of this variability introduced by wireless networks, and will decide that it has reached the optimal when in fact it could have gone further up. And so with this, we can help when it is TCP, which is the majority of more than 80 to 90% of internet traffic. And the solution that we offer involves installing one of our appliances inline. You make traffic go through it, and then what we do there is what technically is called a transparent TCP proxy. And this is something that's been done for a long time, for over 20, 30 years by satellite networks, for instance, or also for 5, 10 years by large cellular carriers like AT&T, Sprint. They have this functionality in their networks because it helps them. But the problem is that so far it's fairly expensive functionality. So we think we have made this functionality available for smaller networks. So how does it work? Well, let's imagine we have these two servers on the right. And these two servers have to send, this is an example, just 7 packets. And they'll do this as in 3 rounds, this probing. They will send 1, 2, 4 packets. And then when the clients on the left get their packets right, they will send an acknowledgement packet saying, oh, I got that right, send me more. And this is a very simplified way in which TCP does this probing. Okay, and so on top will simulate the situation without our appliance. In the bottom, we'll put our appliance somewhere in between. If it's 5 seconds, in this case, 2 and 3. And we'll show you how just placing an equipment like ours makes the network more faster. As we get the first packet gets to us, we will send an acknowledgement on behalf of the end user saying that it's already arrived. So when the server gets this acknowledgement from us, it can then send the second round. And this second round we will keep in a buffer so that when the real acknowledgement from the end user arrives, we can already send it. And with that, for instance, in this example, we've gained 4 seconds over the top path. And the same will happen with following rounds. We'll gain, in this case, 4 seconds each round, except for the first one. And so in this case, if this is 17 seconds that, for these 7 packets, on the top, it'll be 8 more, so 25 seconds. So this is one of the mechanisms with which we accelerate, by placing, because of this buffer that we have on our appliance, the end user is feeling as if the contents are coming from closer, from 3 seconds instead of 5, because when it sends the acknowledgements, it gets the responses earlier. So getting contents closer means getting them faster. It's just, in communications, it works like that. And also, a further gain you gain with this is that if you imagine you have any packet losses between our device and the end user, and in that case, TCP has no problem. In those acknowledgement packets it sends, it can send information, I'm missing such and such packets, so they'll be retransmitted. But now we can retransmit them from our device, which is closer than if those retransmissions have to come from the real server, which may be somewhere else in another state or in another country. So that makes it faster. So that's the second way in which you accelerate. And the third way is when we send out the packets from our buffer, we send them out using our own TCP, which is just a slightly modified version of the standard TCP. We have added an algorithm which we have patented a few years ago, which is basically can do much better the detection of when you reach the optimal network limit. So in this probing, this going with 1, 2, 4, 8, 16, well, this probing that TCP has to do, the algorithm that decides when you've reached the optimal and when you stop ramping up, we have improved it so that it doesn't get confused with the variability that there are, the variability or the random losses that you many times have in wireless networks. And so the end result of all this is we can measure this an improved speed. And we can show you this, and this is a graph with a lot of numbers. Let me explain that carefully, but it has all the ingredients here. When we put, we have our system, as Mike said, is in operation in over 60 networks worldwide, and here's 12 out of those, an example. Different ones to show you that it works in different networks, in both fiber, cable, mobile, cellular networks, WISPs, and in every time we leave, all the traffic is going through us, and we leave 1% of TCP connections at random without any optimization. In this way, we still measure them, and we have something to compare against, because otherwise, what would we compare against to show you that we are accelerating? So we measure those without acceleration, the ones with acceleration, and here's what we are showing. And in this case, we are restricting this analysis just to Netflix downloads coming from Netflix, just to make the downloads more comparable one to each other. So in gray, we are showing you the average speed of downloads without acceleration, and in red, with acceleration. As an example, for instance, in the fourth, the WISP, where it says 1.04 and 2.5, that means that on average, this is data for over a week. There are millions of downloads, so this is just an average speed. On average, Netflix was sending at 1.04 megabits per second. All the downloads were happening at that speed. The connections that were getting accelerated were going at an average of 2.55. So Netflix was deciding to send at 1 megabit per second when it actually could have sent at 2.5, because we were sending at 2.5 and it was going through. So the network is the same, it just has our device. But the users will get out of this a better experience, because if on average, here, okay, there's 1.04, but it could be, there's a large variability, as you can imagine, in a whole network. But on average, they will be getting a better experience if they're having a faster flow of data from Netflix. It's just fewer reloads, rebufferings, fewer high resolution. That's what you would expect. So this is what we can do regarding acceleration, make it faster. And we've talked a lot about Netflix only because it's the main volume that we see, that the volume producer. But for us, TCP is the same from any application. So the other thing we can do is, since data is flowing through us, and we can tell you what kind of, we can identify what is flowing through your network and give you that information. For instance, this is an example. This is a network we have in Italy that has 14 gigabits per second maximum speed. And we show at every time this is 3 days of data, what is the breakdown of services, how much Netflix, YouTube, and different services that they have at each point. And this information may be interesting for you, maybe to see, the peering, which is the content that is becoming more popular in your network, maybe in some cases what to do about it, if you ever have to limit anything, maybe what you would limit, or how to get a better peering to get a better service for each of those services. So we can also give it to you all aggregated instead of over time. And we also can do an analysis of, for instance, this would be an analysis of the top 30 users in your network, and see if there's any pattern that may be interesting when you see what your top users do. In this case, for instance, this is a small network, and they have a basic limitation of 6 megabits per second that's their main plan. And they have this user that seems to, when he connects, he just stays at top speed all the time. Maybe he has a virus or something that forces this, or maybe they have to offer him a better plan. You don't have enough speed, maybe you go to a more expensive plan, or, well, we give you this information and you can work with it. And next, the next thing that we can do is, since we can see what is flowing, identify the different services, we can also apply limitations to those services if you need those limitations at any time. Maybe, for instance, for congestion reduction at certain times when the network is at the peak, for example. So you can limit all kinds of, but limiting certain applications doesn't really make a lot of sense. For instance, if you limit video streaming, which is in fact the largest volume producer in general in most networks, the good thing is that nowadays they use a technology called ABR, adaptive bitrate. So if they have the clients of YouTube, Netflix, and all that, they see that the network is going slower, maybe because you're limiting that, they will adapt to that and send at a lower resolution, which means that they will use less volume. For instance, we did this experiment with Instagram TV. They all work similar. If you don't, for instance, a 2-minute video of a guy doing surfing took 24.8 megabytes without any limitation. But If you limit it to, for instance, 1 megabits per second, is 6 times less. Of course, with 1 megabit per second, the quality is not the same because it will adapt with very much lower resolution. But with 2 megabits per second, the quality will be quite acceptable in any kind of portable device. Not so with maybe with a TV set. But then with a TV set at 4 megabits per second, the quality will be very good. You can get up to very close to full HD. So the thing is that if we limit, for instance, email traffic, the download, for instance, the attachments will take longer to download, but you will not get any volume reduction because the attachments are that size, and people will just get maybe angrier at you because the network is going more slowly. But if you limit video streaming in certain situations, maybe some guys in your network will not get 4K resolution. They will get full HD. Well, which is not so bad. They will probably not complain a lot. However, as a result of doing some limitation, the overall network quality may be better. Because if you're at, and it may not happen in your network, but sometimes it may happen that there are certain conditions where there's an overall congestion. So by reducing it, you are actually delivering better quality overall to the majority of your customers. So, for instance, we did this experiment in this WISP for 4 days. We limited all the video streaming to 4 megabits per second. And only the video streaming, the rest was not limited. And we did, and it was 4 megabits per second per user, okay, of any video streaming, whether it was YouTube or Netflix, whatever. And we did it so that on even hours we did this limitation, odd hours we didn't do the limitation, just to see what happened. And we were measuring, here you can see that in red the hours where we were limiting, and that was the volume that we measured over the whole network. And in gray, it was here on the left, the hours when we were not limiting. And you can see that the overall traffic, how much traffic was going, it was getting limited in especially during the peak times. And the reduction, when we measured it, was around 15%. And not only that, I mean, so nobody complained. That was a good, with 4 megabits per second, you can do Netflix at near to full HD, or 2 Netflix at slightly lower, so people don't complain. It's not something that will get people angry. But maybe overall, if that network was getting into a saturation situation, overall it was going better. And we saw that, in fact, because we were also measuring at the same time for the average latency. And that's on the graph on the right. And so we saw that the average latency was going down by 5 milliseconds. And so that meant that applications like online gaming or voice over IP were probably doing better. And the reason for all this is because many times, if you unlimited things like Netflix and all that will take basically all the bandwidth there is. And that will, in general, statistically, it will fill up buffers. And when the buffers fill up, you'll get more latency. So this is an interesting example of what then we get. This guy, for instance, he just left this limitation, but he left it, and because we allow you, we allow you to configure this in a very easy way. You set, for instance, in this speed here on the left, you have 4 megabits per second. You set that. You set to which customers you want to apply this, because maybe it's only some part of your network that has some congestion problems. So you, with IP addresses and VLAN tags, you can select to which these limitations will apply. Then you select to which content. We have predefined signatures and all that. You don't need to worry about the domain, exactly how to specify that. And we allow you to set it so that you only do this limitation when the whole network, for instance, in this case, if it is a 1 gigabit per second network overall throughput, when the overall throughput is above 800 megabits per second. So you can do this only when the network is getting very close to maybe 80% of its throughput. Because maybe probably out of that region, you don't care if people, you don't need to limit any application. There's probably not so much gain for you or for anybody. So the advantage that, I mean, there are many other, we know that there are other systems that can do this application-based shaping. The good thing that what we think we bring that is better than in other cases is that we can do this while we do the optimization. So we are doing acceleration and limitation at the same time. So for instance, in this example with 4 megabits per second, maybe the sessions that were going, connections that were going at 0.5, we are helping them and getting them up to 1 point something megabits per second. So helping those situations in which they have a problem getting to good Netflix conditions. But what we will not do is, for instance, the ones that are at 3.5, we may get them to 4, but no, we will not then let them go beyond 4. So while we are limiting, we are also helping those connections that have lower quality. And even more, when we do the limitation to the TCP part, we do this in a way that unlike other systems, we can do this without dropping any packets. Because the acknowledgement packets we send back to the server, they also have a field where you can tell a window how much more data you can get from the server. So you can tell the server exactly at what speed to send. So you can set it to send you at 4 without needing to drop any packets. So while we are doing this limitation, we are always focused on doing it in a way that you still have the best available quality. And the deployment, we think, is, we have seen that it is very easy. We don't use IP addressing. You just put in our device inline. It works, let's say, like a 2-port switch. Whatever comes through one way, it will go out the other way. Well, in fact, like a number of those switches, because you can have three or more couples of ports. Everything that comes in through one will go through the other. You can set up through us, for instance, aggregated bonds, aggregated links. They will go end to end because we just forward packets as they come. Then we need one connection for the IP, an IP address for the management. And then we always set up and recommend to set up a bypass link as a security for redundancy. So any mechanism, for instance, the LACP aggregated bonds or MikroTik active backup, I think it's called bonding. Anything that you would do to protect one link that you have, and when it fails, so that it goes through another link, is what we use for redundancy. The hardware we use is we provide either one lower cost unit, $1,500 unit. It's a standard server for MikroTik. MikroTik, Supermicro, and they. That goes up to 10 gigs, and it has SFP plus and also RJ45 ports. And you can also go for a server up to 40 gigabits per second. It's around $4,000 in that. Both of them 1U rack. Okay, the pricing, we offer a monthly charge. Or you have to buy, or sometimes, in fact, if you have certain hardware that we approve, we can use that. Okay, it's just that Mike he can send you the other stuff already all configured to you, and so that you can just plug it and start playing with it. And the monthly charges, for instance, a 1 gigabit system, because the license is based on the top throughput. So up to 1 gigabit, it would be 304, and then it keeps dropping the price every additional gigabit. It'll be at the end $72. This is a monthly charge. We also offer a one-off license if you prefer. These prices are online, available at Solutions for EVs in their site. Okay. And well, what else can I tell you? The best thing would be if one of our customers, like Gino Villarini from Aeronet, one of our customers here in the States. We have 6 customers now live in commercial service, but Gino is our more recent one, and he maybe can tell you more. So thank you.
Thank you. Good morning. It's a little bit tough being here at 8 a.m. on the last day of the convention, but appreciate every one of you this year. I think what we have to, the message that we can convey about the solution is that, at least for us, is that worked wonderfully. I will be frank, the first time we heard about the solution, we were kind of skeptical about it. Was like what is this, like black magic or something like that? So, but we kind of approve a trial, and we decided to give it a ride to see if the Bequant platform will achieve what we were saying. So we agreed to the trial. We received the equipment, and we put it in place, and it worked for us. I got some details about our implementation that I would like to share. In our case, we are in Puerto Rico, so by default, we have an average of a 30 milliseconds latency between the island and our upstream provider, which is in Miami. So having just that latency in place creates like a perfect scenario for the device to enhance our services. We received the device. The guys shipped one device to us, the 10 gig device. We put it in place in line between the gateway and our edge router. And the device was on for about 1 week, if I believe, without being active. It just was collecting stats and information, traffic passing through it. And then the options of the TCP acceleration were activated later on. And what we saw was that our average traffic before the acceleration was about 8 gigabits per second. And as soon as the device started to optimize the TCP, the traffic jumped to about 9.1 or 2 gigs per second. So it grew about 15% of traffic just after turning the device on. So for us, that was kind of an interesting observation because that meant that our traffic was getting into a bottleneck somewhere. Obviously, we didn't know where, and the Bequant device helped us clear out that bottleneck. On the big downloads, we saw a improvement of about 100%. That's obviously big downloads and big huge files and big Netflix streaming. So that was also very helpful for our operation. In the support side, we did see a decrease in the calls from our customers, calling us, reporting some issues with buffering or latency-related issues or gaming. So this is a little bit more maybe subjective or anecdotal, but what we saw was not demonstrated on the graphics on the platform, but we saw a decrease in calls on tech support people, so that also added benefit for us. So we were pretty happy with the device. We agreed to move from testing phase into full implementation, and that's where we are right now. We are moving from the 10 gig device to the 40 gig interface device because we're obviously growing in our traffic, so the 10 gig is too small for us, so we're jumping into 40 gig device, and we're pretty happy about it. we're not using the DPI yet because the device that we have is a little bit limited in memory, so it cannot run the DPI. But as soon as we have our 40 gig device in place, we will start to also use it. So I don't know. That's all I have to say. We're pretty happy about it. I recommend the Bequant people. The staff have been very supportive, very easy to reach, very helpful. It's just there. It's doing its works. Doesn't need any tweaking or anything like that. We haven't had any issues. We haven't need to call the Bequant tech support. So it's good. So I recommend it. Any questions? If you have any technical questions, I have my head network engineer here, Luis, please. He can answer all the technical questions because those are above my pay grade.
So you said something interesting. I'm a metered service, and I was hoping it was going to make my customers use more data. You're saying that it actually made you use more data off your primary connection?
Yeah, the traffic increased about 15%. So that, for us at least, it meant that our customers were being bottlenecked somewhere, so possibly retransmissions or TCP acknowledgements or something. So that was basically clear out of the equation.
So you believe you've improved your customer service?
Yeah, exactly. Yeah. And for the feedback that we have from our customer support department is the experience of the customer has improved a lot. Thank you. Any other questions?
You know, I've got a question for you.
Yeah, sure.
Because I know you guys spent a lot of time testing this out. What did you see on speed test? Did you have any feedback on running speed test?
Good question. Luis, do you have any feedback on that? Yeah.
So you had no impact at all when a customer would run a speed test, they would see no difference with the Bequant device.
I think we saw a impact on the speed tests being done out of Puerto Rico. Obviously, there are several servers within the island, so the performance we have peering, so there's not a benefit in the local. But when we test out to Miami or other points in the States, then we saw a huge improvement on that side. So it's good for us because not only our customers can do a speed test to a local network in Puerto Rico, which is not a real speed test. They can test their service to basically the internet, which is for us is Miami or any other point in the States.
Did you implement throttling along with your implementation?
Yeah, we actually on our we use a Procera device for managing queues and throttling. Luis, is this after or before the big one? After. So it's in line after the big one. Any other questions?
I just wanted to point out too that we play well with other DPI products because he's got Procera. If you got Sise, certainly Preseam. So keep that in mind too.
Yeah, we haven't had any issues, moving the traffic from the Bequant to the Procera. It's just like seamless. No?
One clarification. Yeah, when you mentioned that, his traffic has gone up by 15%, but it's also because he's using just so far the acceleration. We are really looking forward to now being able to implement the DPI because you can sometimes also limit some of
Right,
these.
yeah. With the DPI, we can eventually identify some patterns of traffic that might not be contributing to the user experience. No, we're good? The bar is open. Thank you, guys. Thank you to the Bequant people.
So again, what I'm hoping for, I'm a metered service. What I'm really hoping for is, because of the adaptive bit rate, that the quality of video being sent is going to increase to my customers and they're going to use more data.
Yep. Yeah.
I want that to occur.
Ah, okay. Yeah, no, the thing is that, well, there's always a compromise. Yeah, people do want that in the sense that, I mean, more quality, you need more bits. There's no magic there.
Sell you more.
It's just that sometimes in some networks that may be a problem at certain times of the day.
Yes.
So and sometimes it may be like a temporal thing, you know, like the time it takes for you to upgrade your uplink. Sometimes that takes some time. We can help during that process with that, because eventually, of course, you'll have to go up. If you give more quality and you'll get more customers, then your bandwidth will increase, and it should be a good thing.
Well, assuming there's no other questions, I just want to point out that we are finished, so you get a little break early on this one. However, we would love for you to drop your business card with one of the guys from Bequant in the white shirts with the red Bequant sign on her shirt. If you do that, you're eligible for is it 3 months? Is it 4 months free service for your Bequant device? We're going to have a drawing later today. What time is that drawing? Do you know? At 3 o'clock or close to 3 o'clock? Okay, yeah. They're in the exhibit hall. So yeah, please drop your business card off. And again, you're still eligible for a free trial regardless of whether you win or not. You'll just get an extra 4 months of free service on top of that. So again, appreciate everybody coming. Thank you. Come by booth 501 with the Bequant guys. I'm in 600. We're right next to each other. So thank you.
Can I apply for the free 4 months? No?